now we're going to talk about the PrE BIcH. Okay? And so this stands for something. It's as in pretty female dog, so I'm not saying bad word here. Okay? And so what we're going to do is we're going to go through, and I'm trying to come up with a way to be able to relate vapor pressure, boiling point, the rate of evaporation, the delta H vape, all to each other, and so, and IMFs, all to each other. And so that was kind of the arrangement of the letters that actually was like the easiest one to remember, okay? So first thing it just says is that molar heat of vaporization or fusion is typically measured in kcals per mole, okay? And the second thing is energy can be measured in any of these. It can be joules, it can be kilojoules, it can be calories or kilocalories. And we already talked about exothermic and endothermic, so it depends on whether energy is absorbed or energy is being released, okay? So we're going to try to relate these. This P here actually stands for vapor pressure in my situation. So that stands for the vapor pressure, which again is the pressure of the gas above the liquid. RE is for the rate of evaporation. So how quickly is it evaporating? Okay, how quickly is it evaporating? Is your substance evaporating? But I have a line, okay? So that's my PrE in pretty. And those two go together. In other words, if my substance is evaporating at a fast rate, then I have a high vapor pressure because I have more gas above the liquid. So those are directly related to each other. Now these three are going to be directly related to each other. The B is for boiling point. In other words, the temperature at which the vapor pressure is equal to or greater than the surrounding. I, which is for IMFs. And CH is delta H vape. In other words, it's the energy in order to vaporize. Okay, the energy to vaporize. So the way that this works is these three are directly related to each other. In other words, let's say that you have strong IMFs. You have a substance that is held together really tightly. Is that going to have a high boiling point, or is it going to boil at a low temperature? High. It's going to take a lot of energy to get it to boil, which means the energy to vaporize it will also be high. Again, strong IMFs held tightly together takes a lot of energy to be able to get it to boil, meaning that your boiling point will also be high. So you can see that if your IMFs are high or your boiling point is high, then your delta H vape is also high. But if you think about how fast it's evaporating, if it has strong IMFs and the molecule is held together tightly, is it going to be evaporating fast? No. So your rate of evaporation is actually going to be low in that case, and if it's evaporating at a slow rate, then it also has a low vapor pressure, okay? So what you basically do is you can be told any one of these. You're told one thing, and by being told one thing, you can figure out the other four. For example, let's say that I tell you that some substance A has a low boiling point and some substance B has a high boiling point. So what you're going to do is you're going to write PrE BiCH. And then you're going to put A on one side and B on the other side. And we said that A has a low boiling point, so I'm going to come over to boiling point and I'm going to say that A is low and B is high. So if this is low, then what about these? They're also low. And if this is high, then this is also high. And what do you know about these? It's the opposite. So if those are low, those are high. And if these are high, these are low. Now it doesn't take more than like, I don't know, that was probably 30 seconds, not even, to be able to do that. And once you have this, I can ask you any question. For example, I can say, which substance A or B has the stronger intermolecular forces, IMFs? B. Why? Because that's high for IMFs. Which one is evaporating at a faster rate, A or B? A. So let's circle A. Which one has takes a less amount of energy to vaporize? In other words, the delta H vape is lower. A, right there. Okay. So you can answer any of those questions just based on the one thing, and that's how that chart works. Okay. So let's come down to this chart just to try to make sure that we're okay with this. So we've got in this chart vapor pressures at various temperatures. So you can see temperatures increasing, going down. And we can see that we have four substances, different alcohols, butanol, methanol, propanol, and ethanol. And these here are what? Well, it doesn't tell us anywhere in this chart, but it does tell you right there. What are these representing? Vapor pressures, okay? So if you do a PrE BIcH chart, PrE line BICH, then which one of these am I given? Am I given PrE, BI, or CH in this chart? Wrong. I'm not given delta H vape. What am I given? P. I'm given vapor pressure. Okay? So be careful with mixing that up. That's delta H vape. I don't know if I just misheard. That's vapor pressure is P. Okay, so you're being given the vapor pressures in this chart. It says it right at the top there. All right? So now, the question is, do I have to write all four out? No. You're going to choose the high and the low. Doesn't matter what temperature you look at. I just wouldn't look down here because I only have one. So it doesn't matter what temperature. Let's look at 10 degrees. What's my lowest one at 10 degrees? Butanol is my lowest. And what's my highest? Methanol is my highest. Look at any temperature and it should be the same. At 50 degrees Celsius, butanol is my lowest and methanol is my highest. At 80 degrees, butanol is my lowest and methanol is my highest. Again, that idea that as you increase temperature, no matter what, for every single liquid, your vapor pressure will also increase. Okay? So now I'm going to write this based on just butanol and methanol. And I know that my vapor pressure for butanol was my low and my methanol was my high. So then that means that this is a low, which means the rest of these must be high. And if this is high, then the rest of these are low. And then you would answer the questions. Okay? The first question asked, what is the normal boiling point? Well, again, normal means that your pressure of your atmosphere is equal to what? 760. 1 atmosphere, but this is not in atmospheres. What do they say they're giving this to you in? Torr, or millimeters of mercury. So we're talking about 760 millimeters of mercury. So where's the normal boiling point? Well, normal is when the pressure is equal to your pressure surrounding, which in this case is going to be 760. So let's look at butanol. Between what two temperatures will butanol be boiling? 100 and 110. Perfect, because 760 would fall right into there. So that would be between 100 and 110 degrees. What about methanol? Where would that fall? Good, there's 760 right between there. So if you come back, that's between 60 and 70 degrees Celsius. What about propanol? Yep, right there. 760 would fall there, so between 90 and 100 degrees Celsius. And what about ethanol? 70 and 80. And so, again, that's where 760 would fall. Okay. Which one has the strongest IMFs? So take a look at your PrE BIcH chart. We're looking under the I. Which one's the strongest? Butanol. Which one's the weakest? The lowest is, we're talking about IMF, so right here, methanol. Which has the fastest rate of evaporation? So go to your rate of evaporation. Which one's fastest? Methanol. Which one has the highest delta H vape? Butanol. Very good. Each organic alcohol is placed in a flask and attached to a vacuum pump. If the pressure is reduced to 100 torr at 60 degrees Celsius, which one's boiling? So let's come to 60 degrees Celsius. So we're looking right here at 60 degrees Celsius. Remember, by definition of boiling, boiling is when your vapor pressure is greater than or equal to the pressure of the atmosphere or the pressure surrounding. So let's look at the chart at 60 degrees. And at 60 degrees Celsius, if your pressure is 100, which ones are, which ones are boiling? All of them. Why? They're all above 100. Awesome. All of them. If the flask is cooled to 50 degrees, so now we're looking here at 50 degrees, now which ones are boiling? Methanol and ethanol, because those are the ones over 100. Methanol and ethanol are the ones over 100. Okay? And that's it for the PrE BIcH chart.